De Moivre's theorem, LAQ. Here given question, if n is an integer, then show that LHS value 1 plus I whole power 2n plus 1 minus I whole power 2n is equal to 2 power n plus 1 cos n pi by 2. Now start the solution. Given LHS is equal to 1 plus I whole power 2n plus 1 minus I whole power 2n. Now consider 1 plus I is equal to, now here multiply divided by root 2 is root 2 by root 2 into 1 plus I is equal to root 2 into 1 by root 2 plus I into 1 by root 2 is equal to root 2 into 1 by root 2 in terms of cos value is cos pi by 4 plus I into, here also in terms of sin is sin pi by 4, 1 plus I equals, okay. Next, now 1 plus I whole power 2n equal to root 2 power 2n into cos pi by 4 plus I sin pi by 4 whole power 2n, okay. Okay, 2 cancel here. Now apply De Moivre's theorem. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta in right side. Then implies 1 plus I whole power 2n is equal to 2 power n into cos n pi by 4 plus I sin n pi by 4. Let equation number 1. Similarly from first equation, consider 1 minus I whole power 2n is equal to 2 power n of cos n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. Let equation number 2. Now add equation number 1 and 2. Then we get left side value is 1 plus I whole power 2n plus 1 minus I whole power 2n, which is LHS of given, okay, is equal to, okay, in equation number 1 and 2, 2 power n is common term, 2 power n of, okay, cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4 from second equation. Here plus I sin n pi by 4 minus I sin n pi by 4 both are cancelled. Then we get is 2 power n into 2 times of cos n pi by 4, the 2 power 1 is equal to 2 power n plus 1 into cos n pi by 4, which is equal to RHS, okay. Hence 1 plus I whole power 2n plus 1 minus I whole power 2n is equal to RHS value is 2 power n plus 1 into cos n pi by 4, okay. Hence proved. De Moivre's theorem. Next LAQ. If n is an positive integer, then show that 1 plus I whole power n plus 1 minus I whole power n is equal to 2 power n plus 2 by 2 cos n pi by 4. Okay, now start the solution. Given LHS is equal to 1 plus I whole power n plus 1 minus I whole power n. Okay, from LHS consider 1 plus I is equal to, here multiply and divided by root 2, so root 2 by root 2 into 1 plus I is equal to root 2 into 1 into 1 by root 2 plus I into 1 by root 2. Okay, next is root 2 into 1 by root 2 in terms of sine and cos right here is a cos 1 by root 2 equal value in terms of cos theta is cos pi by 4 plus I into here sine pi by 4. Okay, is 1 plus I equals. Okay, now 1 plus I whole power n, take power on both sides n, so here in LRHS root 2 whole power n into cos pi by 4 plus I sin pi by 4 whole power n. Now apply de Moivre's theorem. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. Okay, this formula apply in above is 1 plus I whole power n is equal to 2 power n by 2, root 2 whole power n is 2 power n by 2 cos n pi by 4 plus I sin n pi by 4. Okay, let is equation number 1. Okay, next similarly we have 1 minus I whole power n is equal to 2 power n by 2 into cos n pi by 4 minus I sin n pi by 4 is equation number 2. Okay, now add equation number 1 and 2, then we get in left side 1 plus I whole power n plus 1 minus I whole power n is equal to 2 power n by 2 is common term of both equations. Okay, here 2 power n, here also 2 power n is common term of both equation 1 and 2. Okay, 2 power n by 2 common, then here cos n pi by 4 plus I sin n pi by 4 sin n pi by 4 from first equation. Second equation is cos n pi by 4 minus I sin n pi by 4. Here plus I sin n pi by 4 minus I sin n by 4 cancel. Then we get here 2 power n by 2 into 2 times of cos n pi by 4. Okay, here 2 power 1 is equal to 2 power n by 2 into 2 power 1 is in the form a power m into a power n is equal to a power m plus n. Then we get here n by 2 plus 1 into cos n pi by 4 is equal to 2 power, take LCM, is n plus 2 by 2 into cos n pi by 4 which is equal to RHS. Okay, hence 1 plus I whole power n plus 1 minus I whole power n is equal to 2 power n plus 2 by 2 into cos n pi by 4. Okay, hence proved. De Moivre's theorem LAQ. Here given question alpha comma beta are the roots of the equation x square minus 2x plus 4 equal to 0. For any n belongs to n, then show that alpha power n plus beta power n is equal to 2 power n plus 1 cos n pi by 3. Now start the solution. Here given equation is x square minus 2x plus 4 equal to 0. We know that x equal to formula is minus b plus or minus under root b square minus 4ac by 2a. Here a equals 1, b equal to minus 2, c equal to 4. Okay, from given equation. Okay, now substitute above values in formula is x equal to plus or minus under root of b square, 2 square is 4, minus 4 into 4 is 16, 4ac is 16 by 2, a 2 into 1 2. So x equal to 2 plus or minus root minus 12 by 2, x equal to 2 plus or minus root 12 into I by 2. Okay, here root minus 12 is equal to root 12 into I square is equal to root 12 into I. So we get here is equal to 2 plus or minus 2 root 3I by 2. Let here alpha equals 2 plus 2 root 3I by 2 and beta equals 2 minus root 3I by 2. Then implies alpha equals 2 is common term is 2 of 1 by 2 plus I into root 3 by 2 and beta equal to 2 is common here also. Here 1 by 2 minus I into root 3 by 2. Okay, now consider here alpha. Therefore is alpha equal to 2 of 1 by 2 plus I into root 3 by 2. Then implies is alpha equal to 2 into 1 by 2 value in cos term is a cos 60 is pi by 3 plus I sin 60 value root 3 by 2. So sin pi by 3. Okay, now consider alpha power n is equal to 2 power n of cos pi by 3 plus I sin pi by 3 whole power n. Now apply De Moivre's theorem. We know that cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. Okay, next alpha power n is equal to 2 power n of cos n pi by 3 plus I into sin n pi by 3. Let is equation number 1. Similarly, beta power n is equal to 2 power n of cos n pi by 3 minus I sin n pi by 3. n pi by 3. Let's equation number 2. Equation number 2. Now add equation number 1 and 2. Equation number 2. Then we get in left side from equation number 1 is alpha power n, from equation number 2 is beta power n. Okay, is alpha power n, here beta power n is equal to, here 2 power n is common in both equations. The remaining terms in right side cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3 here plus I sin n pi by 3 and minus I sin pi by 3 both are cancelled, then we get is 2 power n into 2 times of cos n pi by 3, 2 power 1 here, 2 power n into 2 power 1, we get 2 power n plus 1 into cos n pi by 3, which is equal to RHS. Okay, hence alpha power n plus beta power n is equal to 2 power n plus 1 cos n pi by 3, hence proved. Thank you. De Moivre's theorem LAQ. Here given question: if n is an integer, then show that 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta plus I sin theta whole power n is equal to 2 power n plus 1 cos theta by 2 whole power n cos n theta by 2. Okay, now start the solution. Given LHS is equal to 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n. Okay, since 1 plus cos a submultiple formula is 2 cos square a by 2, 2 cos square a by 2 and sin a is equal to 2 sin a by 2 cos a by 2. Okay, apply these two formulas in above, then we get is equal to 1 plus cos theta, 1 plus cos theta is 1 plus cos a form, so 1 plus cos theta is equal to 2 cos square theta by 2 plus I into is a sin a form plus sin theta is a sin a form I into 2 sin theta by 2 into cos theta by 2 whole power n plus 1 plus cos a cos theta, again 1 plus cos a form is 2 cos square theta by 2 minus I into 2 sin theta by 2 cos theta by 2 whole power n. Okay, is equal to here 2 cos theta by 2 is common term. Okay, into cos theta by 2 plus I into sin theta by 2 whole power n plus here also same 2 cos theta by 2 is common term, cos theta by 2 minus I sin theta by 2 whole power n is equal to 2 power n cos power n theta by 2 into cos theta by 2 plus I sin theta by 2 whole power n plus 2 power n into cos power n theta by 2 into cos theta by 2 minus I sin theta by 2 whole power n terms 2 power n cos power n theta by 2, here 2 power n cos power n theta by 2 is common term, so is equal to 2 power n cos power n theta by 2 is common. Okay, now here apply De Moivre's theorem here also. Okay, so we get here cos n theta by 2 plus I sin n theta by 2 plus here cos n theta by 2 minus I sin n theta by 2. Here plus I sin theta by 2 minus I sin theta, both are cancelled. Then we get 2 power n cos power n theta by 2 into 2 cos n theta by 2. Here 2 power 1 is equal to 2 power n into 2 power 1 is equal to 2 power n plus 1. 2 power n plus 1 into cos power n theta by 2 into cos n theta by 2, which is equal to RHS. If n is an integer and z equal to 6 theta, then show that z power 2n minus 1 by z power 2n plus 1 is equal to I into tan n theta. Okay, here given value is z equals 6 theta. Okay, that is equal to cos theta plus I sin theta, then implies 1 by z is the multiplicative inverse of z. 1 by z is equal to, we know that, cos theta minus I sin theta. Cos theta minus I sin theta. Now consider LHS is equal to z power 2n minus 1 by z power 2n plus 1. Okay, now here take common in numerator and denominator z power n. Okay, then we get z power n into z power n minus 1 by z power n by z power n into z power n plus 1 by z power n. Okay, here z power n both are cancelled, is equal to z power n minus 1 by z whole power n by z power n plus 1 by z whole power n. Here z equal to cos theta plus I sin theta, then z power n is equal to cos theta plus I sin theta whole power n. Then we get z power n equal to, now apply here de Moivre's theorem, then we get cos n theta plus I sin n theta. Okay, similarly we get 1 by z power n or 1 by z whole power n is equal to cos n theta minus I sin n theta. These two values, okay, substitute, let is equation 1, substitute in equation number 1. Z power n value is cos n theta plus I sin n theta minus of 1 by z whole power n is cos n theta minus I sin n theta by cos n theta plus I sin n theta, here plus cos n theta minus I sin n theta. Now here multiply with minus is plus. So minus cos n theta plus cos n theta cancel in numerator, and denominator plus I sin theta minus I sin theta cancel. Then we get here I sin n theta plus I sin n theta is equal to 2I sin n theta in numerator value. Then okay, by here cos n theta is equal to 2 cos n theta is equal to 2 cancel I into sin n theta by cos n theta, it is equal to tan n theta is equal to RHS. Okay, so is hence z power 2n minus 1 by z power 2n plus 1 is equal to I into tan in theta, hence proved. Here given question, show that one value of 1 plus sin pi by 8 plus 1 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8 is equal to minus 1. Okay, let us start the solution. Here given LHS is equal to 1 plus sin pi by 8 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8 whole power 8 by 3. Okay, we know that sin 90 minus theta is equal to cos theta, and cos theta is equal to sin 90 minus theta, and cos 90 minus theta is equal to sin theta. Then sin theta equal to cos 90 minus theta. Okay, from above is equal to 1 plus sin pi by 8 in terms of cos 90 minus 90 means pi by 2 minus pi by 8 plus I cos pi by 8 in terms of sin is sin 90 minus pi by 8 is pi by 2 minus pi by 8. Okay, similarly denominator also is 1 plus cos pi by 2 minus pi by 8 minus I sin pi by 2 minus pi by 8. Okay, we know that pi by 2 minus pi by 8, take LCM, 8 is the LCM. Okay, here 4 pi minus pi gets 3 pi by 8. So right here this whole power 8 by 3 is equal to 1 plus cos 3 pi by 8 plus I into sin 3 pi by 8 by 1 plus cos 3 pi by 8 here minus I sin 3 pi by 8 whole power 8 by 3. We know that submultiple formula 1 plus cos A in terms of cos is 2 cos square A by 2, and sin A equals 2 sin A by 2 into cos A by 2. Apply these two formulas here, 1 plus cos A and sin A. Here 1 plus cos A, here sin A. Next step, apply these two formulas here. Next step, 1 plus cos 3 pi by 8, 1 plus cos A formula apply here is 2 cos square 3 pi by 8 by 2 is 16 plus I into sin A formula here 2 sin A by 2, that is 3 pi by 8 by 2 is 16 into cos A by 2, cos 3 pi by 8 by 2 is cos 3 pi by 16. Okay, denominator is 2 cos square 3 pi by 16 minus I into 2 sin 3 pi by 16 into cos 3 pi by 16 whole power 8 by 3. Okay, now in numerator denominator is 2 cos 3 pi by 16 is common term. Okay, take common 2 cos 3 pi by 16 in both numerator and denominator. Then we get here cos remaining, one more cos 3 pi by 16 here plus I into sin 3 pi by 16 by 2 into cos 3 pi by 16 into cos 3 pi by 16 minus I sin 3 pi by 16 whole power 8 by 3. Here 2 cos 3 pi by 16, 2 cos 3 pi by 16 cancel. Next is equal to cos 3 pi by 16 plus I into sin 3 pi by 16 whole power 8 by 3, and denominator is cos 3 pi by 16 minus I sin 3 pi by 16 whole power 8 by 3. We know that de Moivre's theorem is cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta, and cos theta minus I sin n theta whole power n is equal to cos n theta minus I sin n theta. Apply these two formulas in numerator and denominator in above. Then we get here cos 3 pi by 16 into 8 by 3. Here n value is 8 by 3 plus I into sin 3 pi by 16 into 8 by 3, in denominator cos 3 pi by 16 into 8 by 3 minus I sin 3 pi by 16 into 8 by 3. Here 3 3 cancel, here 3 3 cancel, here also 3 3 cancel, 3 3 cancel. Okay, 8 1s are 8 2s are. Then we get next step, a cos pi by 2 plus I sin pi by 2 by cos pi by 2 minus I sin pi by 2. Okay, we know that cos pi by 2 is equal to 0 and sin pi by 2, that is sin 90, is equal to 1. Okay, substitute these two values here, numerator and denominator. So 0 plus I into 1 is I, by 0 minus I into 1 is 1, so is equal to I by minus I. Here I cancel, then we get minus 1 is equal to minus 1 is equal to RHS. Okay, is hence proved. Here given question, if cos alpha plus cos beta plus cos gamma equal to 0 and sin alpha, sin beta, sin gamma is equal to 0. Okay, then prove that cos square alpha plus cos square beta plus cos square gamma equal to 3 by 2. Same value, sin square alpha plus sin square beta plus sin square gamma is also is equal to 3 by 2. Okay, now start the solution. Here given cos alpha plus cos beta plus cos gamma is equal to 0, and also given sin alpha plus is equal to 0, sin beta plus sin gamma is equal to 0. Okay, now let x equal to cos alpha plus I sin alpha, comma y equals cos beta plus I sin beta, and z equals cos gamma plus I sin gamma. Now consider x plus y plus z. consider x plus y plus z is equal to cos alpha plus I sin alpha x value plus y value is cos beta plus I sin beta plus z value is cos gamma plus I sin gamma. Okay, add three values here, then we get x plus y plus z is equal to cos alpha plus cos beta plus cos gamma plus I into plus I into sin alpha plus sin beta plus sin gamma. Okay, now is implies x plus y plus z is equal to, okay, we know that cos alpha plus cos beta plus cos gamma value is 0, and also sin alpha plus sin beta plus sin gamma value is also 0. Okay, 0 plus I into 0 is equal to 0. Then we get x plus y plus z is equal to 0. If x equal to cos alpha plus I sin alpha, then implies 1 by x equal to cos alpha minus I sin alpha is the multiplicative inverse of cos alpha plus I sin alpha. Similarly, y equal to cos beta plus I sin beta, then implies 1 by y is equal to cos beta minus I sin beta. Next, last one, z equal to cos gamma plus I sin gamma is implies 1 by z is equal to cos gamma minus I sin gamma. Okay, here also add these three values, then we get 1 by x plus 1 by y plus 1 by z is also equal to 0. Now we know that x plus y plus z whole square algebraic form is x square plus y square plus z square plus 2 of xy plus yz plus zx. Okay, next is equal to x square plus y square plus z square plus 2xy is xyz. Okay, take common here xyz, then we get 1 by x plus 1 by y plus 1 by z here. Okay, substitute here x plus y plus z equal to 0, and 1 by x plus 1 by y plus 1 by z equal to 0 here. Then we get here 0 square is 0 is equal to x square plus y square plus z square plus 2xyz into 0 is 0. X square plus y square plus z square equal to 0. Okay, now we have substitute x and y and z values. X value is cos alpha plus I sin alpha, in short form cis alpha. Next, y value cos beta plus I sin beta, in short form cis beta, and z value cos gamma plus I sin gamma is equal to cis gamma. Okay, these three values substitute here, then implies cis alpha whole square plus cis beta whole square plus cis gamma whole square is equal to 0. Okay, apply here de Moivre's theorem. Cis theta whole power n is equal to cis n theta. Then we get here This implies cis 2 alpha here n value 2 plus cis 2 beta plus cis 2 gamma is equal to 0. Okay, next is implies cos 2 alpha plus I sin 2 alpha is cis 2 alpha value, and cis 2 beta value is cos 2 beta plus I sin 2 beta plus cis 2 gamma value is cos 2 gamma plus I sin 2 gamma. Okay, now separate the real and imaginary part. Now real part of above is 2 cos alpha plus cos 2 beta plus cos 2 gamma plus I into imaginary part is sin 2 alpha plus sin 2 beta plus sin 2 gamma is equal to 0 plus I into 0. Now equating on both sides. Equating on both sides real and imaginary parts. Now real part of LHS and RHS is cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 0. Okay, here two cases there. Now case 1. Case 1, apply cos 2a formula. Cos 2a is equal to in terms of 2 cos square a minus 1. Then we get 2 cos square alpha minus 1 plus 2 cos square beta minus 1 plus 2 cos square gamma minus 1 is equal to 0. Okay, then we get 2 of cos square alpha plus cos square beta plus cos square gamma is equal to minus 1 minus 1 minus 1 is minus 3. Take right side is equal to 3. Then implies cos square alpha plus cos square beta plus cos square gamma is equal to 3 by 2. Is equal to 3 by 2. Now case 2. Now case 2, here apply cos 2a form in terms of sin is 1 minus 2 sin square a. 1 minus 2 sin square a. Okay, then we get cos 2 alpha value in terms of sin is 1 minus 2 sin square alpha plus 1 minus 2 sin square beta plus 1 minus 2 sin square gamma is equal to 0. Then we get 2 of sin square alpha plus sin square beta plus sin square gamma is equal to 3. Okay, next is a sin square alpha plus sin square beta plus sin square gamma is equal to 3 by 2. Okay, here LAQ demo. Here Demoivre's theorem LAQ. Here given cos alpha plus cos beta plus cos gamma equal to 0 and cos sin alpha plus sin beta plus sin gamma equal to 0. Then show that first question is cos 3 alpha plus cos 3 beta plus cos 3 gamma equal to 3 cos of alpha plus beta plus gamma, and second one is sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 into sin of alpha plus beta plus gamma. Okay, now start the solution. Here given cos alpha plus cos beta plus cos gamma is equal to 0, and also given sin alpha plus is equal to 0, sin beta plus sin gamma is equal to 0. Okay, now let x equal to cos alpha plus I sin alpha, comma, y equals cos beta plus I sin beta, and z equals cos gamma plus I sin gamma. Now consider x plus y plus z. Consider x plus y plus z is equal to cos alpha plus I sin alpha, x value, plus y value is cos beta plus I sin beta, plus z value is cos gamma plus I sin gamma. Okay, add three values here, then we get x plus y plus z is equal to cos alpha plus cos beta plus cos gamma plus I into sin alpha plus sin beta plus sin gamma. Okay, now is implies x plus y plus z is equal to, if x plus y plus z is equal to 0, then we have x cube plus y cube plus z cube is equal to 3xyz. Okay, now here x equal to, we know that x equal to cis alpha and y equal to cis beta and z equal to cis gamma. Okay, substitute these three values in above, we get cis alpha whole cube plus cis beta whole cube plus cis gamma whole cube is equal to, in right side term, 3xyz is 3 into cis alpha into cis beta into cis gamma. We know that cis theta whole power n is equal to cis n theta, and cis theta 1 into cis theta 2 is equal to cis of theta 1 plus theta 2. These two formulas apply in above, then we get here cis 3 alpha plus cis 3 beta plus cis 3 gamma is equal to 3 into cis of alpha plus beta plus gamma. Expand the cis form is cos 3 alpha plus I sin 3 alpha. Okay, plus second one is cos 3 beta plus I sin 3 beta, I sin 3 beta. Next third one is cos 3 gamma plus I sin 3 gamma is equal to, in right side value is 3 of cos alpha plus beta plus gamma plus I into sin of alpha plus beta plus gamma. Okay, now equating on both sides, then we get is cos 3 alpha plus cos 3 beta plus cos 3 gamma is a real part of LHS is equal to real part of RHS is 3 into cos of alpha plus beta plus gamma is the first results. Now imaginary part in LHS is sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 into sin of alpha plus beta plus gamma. Okay, hence proved. Here given question, if n is positive integer, then show that p plus iq whole power 1 by n plus p minus iq whole power 1 by n is equal to, in right side value is 2 of p square plus q square whole power 2n into cos of 1 by n tan inverse of q by n. Okay, here given LHS equals p plus iq whole power 1 by n plus p minus iq whole power 1 by n is the LHS. Let's p plus iq is equal to r of cos theta plus I into sin theta. Okay, then we get here p equals r cos theta and q equal to r sin theta. Okay, from these two values consider q by p is q by p, then we get tan theta, then implies theta equal to tan inverse of q by p. Now consider p plus iq whole power 1 by n is equal to r power 1 by n into cos theta plus I sin theta whole power 1 by n. Okay, then implies p plus iq whole power 1 by n is equal to r power 1 by n into cos theta by n plus I into sin theta by n. Let's suppose is equation number 1. Similarly, p minus iq whole power 1 by n is equal to r power 1 by n of cos theta by n minus I sin theta by n. Let equation number 2. Now add equation number 1 and 2. Then we get equation number 1 and 2. In left side value is p plus iq whole power 1 by n plus p minus iq whole power 1 by n is equal to r power 1 by n is common term of both equations. So here cos theta by n plus I sin theta by n plus cos theta by n minus I sin theta, here n. Okay, plus I sin theta by n minus I sin theta by n, both are cancelled, is equal to r power 1 by n of 2 cos theta by n is equal to r value. We know that r equal to root p square plus q square. Substitute here under root of p square plus q square whole power 1 by n into 2 cos of 1 by n into theta. Here theta value is tan inverse of q by p. Okay, substitute here is equal to p square plus q square whole power 1 by 2n into 2 cos of 1 by n into tan inverse of q by p. Okay, is equals 2 into p square plus q square whole power 1 by 2n into cos of 1 by n tan inverse of q by p. Okay, is the RHS.